All right, so in this lesson, we will analyze and write equations for arithmetic sequences. So we're going to analyze and write something about arithmetic sequences, right? We're going to do something. Now, arithmetic sequences, first we've got to figure out what they are. They're just like a list of numbers. You see how they're just numbers after numbers, progression of numbers. But we're either going to be adding or subtracting. A lot of people like to, or some people like to describe it as just adding, because you can add a negative number. But I like to think about it as adding or subtracting, because both work. You can see that in this, here's some examples. In this first one, you're adding 3, 3, 3. In this one, we're adding half. Okay, if you don't see it, we'll just keep adding half, 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 half. This one, we're subtracting 2 minus 2 minus 2 minus 2. And remember, these dot, 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 like these ellipses, means it keeps going on forever. We're just not going to write forever. We're going to do it with negative numbers, like here. Okay. Now, we're going to analyze these series. They're going to be given to you in this equation, in this form right here. So this is going to be, well, we'll say that n is the term number. And we'll understand this more in a second. A1, a sub 1 is your first term. D is your common difference. And we'll go over all this. Common difference. And then this is your term number. Again. Term number. So let's go ahead and just jump into it. All right, so in this one, in this arithmetic, well, in an arithmetic sequence that can be represented using this equation, remember that this is how it usually, or it's the form it's going to be in. This will always be minus 1. So this A1. So the first term, so we start off with 10. So basically your list starts off with 10. It's going to add or subtract. So we look at this. This is the common difference. We're adding 2. We're adding 2. Therefore, the common difference, once again, is positive 2. It says the third term in the sequence. So this is the first term. We got to get to the third. So we're going to add, start at 10, we add 2. So then we get 12, 14. Second term is 12. Third term is 14. Cool. So a sub 1 means the first term. First term was 10. The second term was 12. The third term was 14. It wants to go to the fifth term. So let's add 2 again. And we get 16. And then we add 2 again because we're trying to get to the fifth term. And we get 18. 18. Now, let's provide at least some sort of proof. So let's begin with our initial equation. A sub n, or any term number, is 10 plus 2 times the term number minus 1. So let's take like term number 4 here. So term 4, which is 16, it should be 10 plus 2 times the term number was 4 minus 1. So we get 10 plus 2 times 3. Now, I want you to think about it. Why do we take away 1? I want you to just think about it. Like, we start off with 10. Yes, we start off with 10. How many times do we add 2 in order to get to the fourth term? How many times do we add 2 to get to the fourth term? We add 2 3 times. 1, 2, 3 times. What if we wanted to get to the fifth term? We would add it 1, 2, 3, 4 times. You always add it one less time. That's why we subtracted 1. You always add it or subtract it one less time than the term number you're at. That's why we end up with 3. So 10 plus 6 is 16. So a sub 4, which is our 4th term, should be 16. 1, 2, 3, 4th term is 16. Correct. All right, let's try it again. This time we start off, this is a sub 1, this is d. This time we start off with 20. Our first term is 20. And then according to our common difference, we are going to subtract 5/10 every time. Therefore, the common difference is negative 0 and 5/10. Now it wants us to go to the third term. So this is our first term. Remember that we are subtracting 5/10. So we get to 19 and 5/10. We subtract it again for our third term, which is 19. Oh, our 19. So 19 is our third term. Remember, these aren't fractions. I know they kind of look like fractions right now, but remember, these aren't fractions. This 1 is the first term, second term, third term. So the first term is 20. The second term was 19 and a half. The third term was 19. Wants to know the fifth term. So let's get ready. So minus 5/10, which is 18 and 5/10, and minus 5/10, which becomes 18. 18. All right, let's prove it. So let's start off with our equation. Now let's just pick a random one. So let's choose our fifth term again, fifth. So our fifth term should equal 20 minus 5/10. 5 minus 1 times, 4 times. So 20 minus 0 and 5/10 times 4. minus 2 negative times positive negative 2. So a sub 5, the fifth term, was 18, or is 18. All right, that's the first practice. Now let's check out the second practice. All right, so this time we are given a sequence. Now we need to write the equation. Okay? So remember, our equation, general form, is a first term, well, a sub 1, which is first term, plus minus the difference, so to speak, and minus 1. So a sub n equals a sub 1 plus the common difference times n minus 1. Sorry, I don't know why I struggle so much on that one. All right, so we need to know what term we start off with. We start off with 3, so that's going to be 3. And then we need to figure out what we're adding and subtracting by. Here it's easy. That's just plus 2, plus 2, plus 2, plus 2. But you know me, I just put an easy one there just so y'all can see it. But let's say we didn't know this is plus 2. Let's say we weren't very good at adding. All you would have to do is 5 minus 3, the other way around, is positive 2. Let's try it over here. 11 minus 9, remember we go backwards, is plus 2, positive 2. So our general equation is a sub n equals 3, our first term, and then we're adding 2 n minus 1 times. And of course, just like the other one, you can show some proof here. I don't think I need to show you proof. I'll show you the setup to begin with. So a sub, let's try the third one. A sub 3. So the third term should be a 3 plus, remember, 3 plus 2 times the third term, so 3 minus 1. And then, well, let's just finish it since we're here already. We get 2. Okay, and we'll multiply by 2. And we get 7. So our third term should be 7. 1, 2, 3 is 7. Let's do it on... Alright, let's like troubleshoot a couple of these. This one, we can see that we subtract 3, right? Subtract 3, subtract 3, subtract 3. But what if we didn't know that? How could we get that common difference? Well, instead of, you wouldn't do 10 minus 7. Remember, you always like do it in reverse. So 7 minus 10 is negative 3. Like if we're trying to figure out what happens going this way, we subtract, we do the inverse of what we are trying to get this way. What if we did this one, 4 minus 7, and we're going this way, so to speak. So it's negative 3. And what if we did this one, negative 2 minus 1, minus 1 minus 1 minus 1, which is minus or negative 3. So we start off at we start off at 10. And we keep taking away 3 and minus 1 times. And then y'all know how to show proof. Let's try this last one. So what are two equations? Well, make it 1. Make it 1. I don't know why it says 2. What equation represents an arithmetic series if the fifth term is 15 and the sixth term is 14? So I like to do this. 1, 2, 3, 4, 5, 6. So our fifth term was 15. Our sixth term was 14 and a half. Remember, if we don't know what happened going this way, then we subtract going that way. 14 and a half minus 15 is negative 5/10. So let's just double check. Would this be plus 5/10 or minus 5/10? Definitely minus 5/10. Now, we're trying to get back to the original. So we have the common difference. Now we need to get back to the original. So instead of subtracting going this way, we're going to add going this way. I'm not going to draw the arrow because I don't want there to be too much confusion. Or maybe I'll draw a little one, right? So we're going to add. So we end up with 15 and a half, 16, 16 and a half, 17. Once again, general form is a sub n is our first term plus the common difference times n minus 1. So a sub n, first term was 17, or is 17. We subtracted 5/10 n minus 1 times. And you know how to show the proof. Alright, so that's it. Thank you.